Okay, in this video I'm going to talk about the way the error codes or fault codes seem to be displayed in the EDC15 PD files. As in all the other videos that I've put up so far, I'm using the VW Passat PD130 as my guide or my example. And here it is in Windows. Now, if we run through, I won't apologise for the fact that I've changed a few bits and pieces on here, and this is deliberate, otherwise I would have to keep looking up to see what different things were. If we run through this, you can see that what I've done is I've put various notes on here as a reminder to myself. Here we've got fault code. We've got 19587, 19587. And here I've put a note on the actual file to say that that is the equivalent of P3131 EGR system regulation range not reached. So that's that one there. And usually it goes hand in hand with this one, which is regulation range exceeded. But they're not next to each other. They've been moved apart. So obviously that was deliberate. The designers deliberately did that. So we've got here not reached, and there we've got exceeded. So if we look at this one here, which seems to be in pair with it, we have got EGR flow rate, and if I just drag that over so that we can see a bit more of it, that one says XF's detected, and if I go and look at this one over here, it says insufficient detected. So we've got two more EGR error codes. So we've got 1, 2, 3, 4. If you've seen the previous video, you'll know what that is. Then we've got one there, 5, which, as it says down here, is the EGR valve short circuit to battery plus, and that is with EGR control circuit high there. So presumably one of these over here will be a different kind of short circuit. There we go, short circuit to minus or to the ground, and this one control circuit too low. So we've got 1, 2, 3, 4, 5, 6, 7, 8. And if you watch the previous video that I put up, you'll know that that's the maximum. We can only have 8. So if we want more than 8, we need a new fault path. So the designers would have had to start a new fault path. So it's quite possible that something else to do with EGR is down here, or math flow is down here, but it has to be in a different fault path because we've used up the 8 slots that we've got. Now, if this were the previous version of EDC15, prior to PD, these 8 codes would all be in a nice long row, and we would be able to go, oh look, there's 0, there's 1, there's 2, there's 3, there's 4, and so on, up to 7. They're not arranged like this in PD files, so this could be 0, 1, 2, 3, 4, 5, 6, 7, or maybe they're just not arranged 0 to 7. But we've certainly got 8 anyway, and that's why I've made them green there so that they will stand out. Now, anybody who watched the previous video will know that these are the environmental conditions for those faults. So we've got 1, 2, 3, 4, 5. And these don't seem to change from EDC15 non-PDs to EDC15 PD engines. So these seem to represent the same thing. So they will still represent things like engine speed, injection quantity, MAF airflow, EGR values, and so on. So these seem to be representing the same sorts of things. Right, so what else have we got on here, and what do these things mean? Well, if you looked at the last video, you'll know that what we found, or what seems to apply, is that we end up with some numbers associated with the codes. Now, again, we are in the area of how I believe this works, and of course lots of experiments by various people, and myself included, tend to suggest that much of what I'm saying is correct, because it does seem to happen when you make your own changes. you will be able to make changes of your own if you want to test this out on your own car. It shouldn't cause you any problems as long as you're only changing odd values one at a time and checking to see what happens, or maybe two at a time. Right, now what we appear to have here is error debounce, healing debounce. These are nearly always times, but they're not always times. So error debounce, healing debounce, and then possibly a count, but it's difficult to tell because of that. And then here we have something that might have been error debounce and might have been healing debounce, but the figures look odd. So that's different. Then we appear to have error debounce, healing debounce, and possibly a count. Error debounce, healing debounce, and a count. Error debounce, healing debounce, and a count. Now these ones where I'm saying and a count, I am assuming they must be 8-bit, because here it simply doesn't make any sense for that to be a 16-bit number. If I bring that up, it comes up as 49, and it comes up as an 8-bit 49 number, but that's simply because I've been playing around with the settings. But I believe that that is actually an 8-bit 49. If I go to here and just say, let's call it all 8-bit, suddenly it looks a bit more confusing, but there's our first error code, there's our second one, there's our first debounce for fault time, there's our debounce for healing time, and here is what I think is the count, and it seems to be followed by this value 35, which is common throughout the file, so I'm guessing that it doesn't have any meaning, or at least it doesn't have one that I can find. But that gives me my 49 count, so maybe you count 49, and once you've counted 49 you're in error. Over here, similar thing, count to 17, you've got an error. Over here, count to 17, you declare an error. Over here, count to 1, you've got an error. So it looks like what happens is that amount of time doesn't matter, you'll never reach it because it's a massive number that's not going to be reached, so the fault's not going to occur by actual counting time. If it did, it would instantly heal because that's a very, very short time. But here, as soon as it occurs, and I guess that's any more than once, you will instantly get a fault flagged. So that's what I suspect happens with these files. We've got two error codes followed by a debounce to decide if it's an error, debounce to decide if it should be a healed error, and then a counter number to say get that far and then ignore these, just set it because of the count. We are left with that one, and that one. And it's difficult to know exactly what these two are, or these three are, because of the numbers involved. I suspect that this one is what was originally the priority. In other words, instead of going from 0 to 7, I think this now is readable more like this. In other words, this code is the information for that particular point. So if there was a 0 or a 1, that would be something on or off, and 1 there is something on or off, and so on. And so it could well be that the presence of a 1 in a particular spot is the mill light being on. Now if it's the same as the way the original or the early EDC15s worked, then it would suggest that a value here somewhere puts the mill light on. Now usually you find that a value of 2 or above puts the mill light on, and that is 2 there, or it says 10, that is 2. So that would be a value of 2. So maybe this code is telling us there the mill light should be on, and here it's telling us something else about that. I do have an idea about how some of this works, but I'm not 100% sure, so I'm not going to say anything about it here in case I'm explaining something that's completely wrong. But assuming that that is the equivalent of priority, then this would be our count for fault count starting and hill count starting. And again, I believe those are connected with the other counters. So they are the point at which the counter should start. But again, it's very, very, very difficult to pin these down exactly, but it would appear to be that way. And when it comes to the specific faults, it would appear that what they do is when they can, they pair them up as opposites. And so one might be, let's go back to the 16-bit view. So in other words, one here might be for not reaching something, whereas the opposite one over there is for excess. And so then the two are the opposite of each other. So that's what I believe is happening. The only other thing that's not 100% sure is that, generally speaking, you have to do a bit of searching to work out exactly what is paired with what, and this can cause real problems because these two presumably are using those three messages there as their data. And then these two have got this odd little bit jumped in here, which in the old files was at the beginning. Then they've got the ambient or environmental coding, and then they've got that. So I'm presuming that these bits here are for that one. Then these two have got their information right next to them, and then these two have got their information right next to them. So that would seem to suggest that these are for those two. Right, now what I'm going to do is I'm going to stop there to keep this at a manageable length. Then I'm going to come straight back in on another video with exactly the same information. So I'm going to continue this, but I'm going to talk about what we might consider changing if we wanted to make a change to an error code. So I'll stop there first.